Hello, and today in this video I'm going to be talking about some of the key principles involved in a hyperboloid of revolution for the topic of structural forms, and just some of the key principles that will be needed to know need to be covered before coming into this topic and to be able to complete the question like so. So basically we're given a hyperboloid revolution that's cut by an inclined plane at 30 degrees. Just move in there a little bit. And basically, if you draw a planned elevation, project an end view, and find the true shape of one side of the cut section. So basically, obviously, draw the hyperboloid revolution standard enough. So you'll be this question comes from midway through the topic, so you should be able to construct the hyperboloid revolution through any method you want. Really, you can use the asymptotic method as used here, or the rectangle method, or the elements method, obviously. But then, when it comes to the cut section feature of this question, the students will have to have prior knowledge, prior principles, and understand the topic of the cutting planes and the sections of solids chapter, which will be covered in the plane and descriptive geometry section of the DCG syllabus. Obviously, understand principles. Okay, how do we why do we use cut sections, and then how do we represent them? Obviously, in planned elevation. Obviously, so say we have our point C here, or that's C here, and drop that down into our C. Drop that down here into our plan and have our straight line. And then what we do is bring it over to our cuts, our hyperboloid, our curve. Bring it down. That is then our radius. Then that is then our radius. Swing a circle, and where the cuts are C in two places, we will have a point, and we do this for each of our divisions of our cut section. That's how we represent it in plan. And then to find our true shape of our cut section, so we can go get the true shape of this side or this side. It doesn't make a difference, really. It's going to be the same each side. And what's needed to do this is an auxiliary view. So obviously we need to students need to understand that our auxiliary shows true shape and are given shows as a true length, obviously. So we're taking auxiliary of this line here, which represents this half of the cut surface here, and this is our true shape then given. Obviously we use our widths, and our principles from auxiliaries that if we're taking auxiliary from our elevation, we take our heights and our widths from our plan, and obviously vice versa. If we were taking an auxiliary from our plan, we take our heights from our elevation. So this is, and then we just represent it down here for each point. So we have A, B, C, D, A, B, C, D. Exactly. And so this is a couple of key principles needed to complete a question on the hyperboloid revolution, sorry. And obviously we need to know key principles in terms of auxiliaries and heights and widths, and then obviously our sections of solids and our different kind of cutting planes. We can have an inclined cutting plane, we can have a horizontal or a vertical cutting plane also.